My first PR in Rust repo, I think it was improving some of the bridge infrastructure between the Rust language server and the Rust compiler, so that you could more conveniently get the information from the compiler, so that then in turn you can get some nice auto completions in VS Code or Vim or whatever you're using. So we see numerous companies adopting it by default for many large-scale projects. So I'm sure you've heard of Libra, the cryptocurrency that Facebook tried to push like a year ago, I think. And it was written from ground up in Rust. So I mean, this is a very globally reaching project that could potentially influence, maybe not the entire globe, but a lot of people. And it was used already, and it was picked as a main sort of tool. So I think it is getting widely adopted, but I'd say it's gonna take like 3 years maybe for people to be more confident in picking Rust. And that includes also some lesser startups and companies that probably do not have current human resources in terms of like Rust developers, but I think that's going to change. It's going to take like, I don't know, 3 to 5 years. I'd say so, yeah. So we had a trend of microservices, right, where you had dedicated services that crunched this very specific type of thing and then just served it all around. I think this is going to be huge for networking because you're not going to be stuck with the likes of Java or even Node, and this means JavaScript or even Python. I think you can write very similarly in terms of complexity services, which consume like orders of magnitude less amount of resources, and I think maybe networking would be the best. So like backing infrastructure for big cloud solutions, if you may. I think that's going to be the most impacted industry. So there's the book, the officially written book by Carol Nichols and Steve Klabnik of Rails fame. This is not it. This is not a project, but it goes through very practical examples and writing your own kind of project. Where was it? So this is very good to go through when you want to learn stuff. There was a project called, I think, Rust Links, which are officially adopted small exercise to get you used to reading and writing Rust code. And I'll just go here. I haven't used it, so it's kind of hard for me to recommend it, but I've heard from people that did use it that it was very insightful and helpful. So this is like a set of katas to try and, run and do your exercises. So the exercises are sorted by topic and can be found in the subdirectory Rustlinks exercises topic. So I think this is a very good starting point and it's getting continuously improved. So I'd say look there first. So there's grade this week in Rust, which is, as it says, weekly updates. So you get blog posts, announcements, what is grade of the week, call for participation, which is very cool. So you can see what you can pick up if you want to be included in the community and work on stuff, but also there's updates from Rust core. So what core changes were made to the core language itself, and also events, which is very cool, jobs, code of the week, super cool in terms of knowledge and compactness. But also they're very often reposted to Rust, and this is a very good and my main source of news. So as you can see, just everything clicked. So yeah, I'd say that's it. That's a very good issue. I personally think that single biggest issue, I think we haven't really worked out whether we want to be technically precise or being more approachable for users. So there's been a trend of downplaying some of the technical jargon, which means I'd say you neither get the benefits of being user approachable and you also don't get the benefit of being technically correct. And I think that line's gonna cross over to language itself, and it has already happened. And this can be a source of confusion, so to speak. So Rust language is, I think, the most prominent example in this case as impl trait. So you can write a simple function that accepts argument, which implements a given trait, right? But sorry, bear with me. This is going to be a little bit more verbose or not so concise. So what this means, this is a syntax trigger for a generic function that just is generic over type T, and it has to implement my trait, right? So this is a function that accepts any T that's generic, and then it does something with it. But also there's another syntax, which you do impl trait in return position, and it returns a specific, like there exists a type that implements this trait, and it just basically what this is a type erasure. You return a type, return a value of that that implements that type. But the problem is you use the same syntax and you talk about the same stuff, but conceptually it means two very different things in terms of language design. And sometimes you get the error messages that are harder to grasp because they make more sense in one case and not the other. And I think these small kind of conveniences may make the language more confusing and harder to adopt, basically. So I think this is the biggest issue. So Go is nice because you can include the runtime, so to speak, and provide a very portable binary that just executes and does what it does. But I think Rust gives you this more, more oomph, like the edge in terms of control and performance, because you're not conformed to a given, let's say, green thread runtime or Go routine model. You can just write your code, which is async and based in channels and everything, but not tied to a specific runtime. And I don't have any example handy, but there was a post where I think Amazon tried to tweak their implementation, and originally they used Tokyo, which is a very cool library-based runtime for, I'm not going to repeat this, a runtime for writing reliable asynchronous application with Rust. And they wrote their software having this in mind, but they also needed to tweak the performance characteristics of their own runtime. So what they could do is they could just swap the internal implementation of the runtime underneath, because it gives you more control. And it turns out like controlling those knobs and tweaks gave them substantial amount of performance that they would not have by sticking with a specific implementation. So I think this is the biggest factor, that you get more control. And also we have generics, so. So RLS directly, so what Rust C does is it can emit the errors that are machine readable. And there's a tool called Rust Fix, I believe, that automatically applies the suggestions that were made by Rust C. And this is a tool that was mainly used to to transition to Rust edition 2018 because Rust has two editions, the basic one 2015 and the revised one 2018, which is they use different syntax, but it was breaking change, so we had to split it up. So what this tool does is it runs the compiler, it asks it to emit the diagnostics in a machine-readable format, sorry, and then it applies it directly. So RLS, Rust Language Server, also has the same kind of machinery involved, where it invokes the compiler and then proposes some of the kind of light bulb, quick fixes like you would know from IntelliJ, so this, IntelliJ or VS Code. So this uses the same mechanism. But if you're talking about specifically a tool that does the code proposals, then I'd say this is the tool. It automatically does it for you, or you can use the, wait a moment, the extension. You can use this. I'll try to link it. Or you can use the great, I hope they started publishing Rust Analyzer, which is another IDE tool for VS Code, but I can't see it. I'm sure they have. Oh, wait. Oh yeah, there's Marketplace Rust Analyzer. So also give that a try. And this is also going to offer some code suggestions. So yeah, I really hope you're also hooked up like I am, because this is a very interesting and exciting time in terms of like programming and IT landscape, where Rust just makes it a lot easier and faster and safer by default. So I think this is a game-changing technology, so to speak, and I'm excited to see more and more software being written in Rust. My GitHub is this. I'm not doing that much open source work as much as I'd love to, so I still work on RLS, I still work on Rust, which is here. I just do, a few commits every now and then. I think recently the most cool thing was adopting the most commonly used JSON deserializer and serializer to no std, which is a target that does not require operating system, so it can be used in WASM and embedded. So I think that was the most exciting stuff that I did recently. There's something, no, not here. Well, yeah, that's the feature. So yeah, not as much as I would like, but some now and then, sure. Cool, so you can follow me here. That's my GitHub, if you're into that, if you're using social aspects of GitHub. I'm also here, but I'm not as active. I do some of it, so you can follow me as well. And if nothing, you can just send an email to zanewalk, which is my main handle used everywhere, at gmail.com to reach me. And also, after this, I have these resources, but I have quite quite more of them. So I'll surely just send all that after the webinar. So we don't need to, yeah, I'll just share it later with you and somewhere that I have. So you can explore the glorious landscape of Rust. Okay. Cool, glad I could share some perspective on Rust. Okay, thank you very much for tuning in, and please reach out to me if you have any questions or want to work in Rust and don't know where to start, I hope the materials and the content was also a good starting point. I'll see you soon then. Thank you, and bye-bye.